So, these are questions that you should have done yourself before. Actually, all of your notes are questions you should have done yourself first. But what methods do we know how to find maximums of functions? So, something I would expect you to say is like use the derivative. So, when the derivative, I'm just going to this is not written formally, changes from positive to negative. And again, this is not formally, I would never actually write that on like an exam. So when derivative changes from positive to negative, that's a maximum. You could have also said use a graphing calculator. Like if you graph it, you can figure out where a maximum occurs. All right. If you know there is a maximum at x equals c, does that mean the derivative has to equal 0? So no, it does not. Because f prime of c could be undefined. So for example, you could have like a negative absolute value and your function is not differentiable at x equals c. And then if a maximum is at x equals c where f prime of c does equal 0, so in this case, we know we have a maximum where the slope is equal to 0, not undefined. What is f double prime of c? Well, you can see from my picture, my function is concave down. So if f is concave down, then f double prime is negative. Okay, so this is going to be both of these points are going to be really important to this chapter. So understanding that if you have a maximum, it's when f prime of c is equal to 0 or undefined. That's why this is not enough to justify a maximum or a minimum. And then if you have a maximum and you already know the slope is equal to 0, you can tell that a function is concave down. Okay, so this is another important point that a maximum can occur if you know your function is concave down and your slope does equal 0, then that will create a maximum. So that's going to be a huge point for this chapter as well.